a brief problem on calculating the Thevenin equivalent circuit, that is the Thevenin equivalent resistance and voltage for a simple voltage divider circuit. Shown here is an 18 volt DC power supply, and going across it to ground are two resistors in series, a 12 kilo ohm and 2 mega ohm resistor. And we're interested in the output of this voltage divider right here, which I'll label V out. And when it's unloaded, that is of course the Thevenin equivalent voltage. And that's the first thing I'm going to calculate using the voltage divider equation, which is the lower resistor value, 2 mega ohm, over the sum of the two resistor values. So it's 2 mega ohm plus 12 kilo ohm. And that's going to be a number. Of course, this is times V in there. So that'll be V in times a number that's going to be pretty close to 1. My calculator out, that's 2 mega ohm divided by 2 mega ohm plus 12 kilo ohm. And that number is 0.994, or 18 volts times 0.994, or 17.89 volts. It's a very small change in voltage because the lower resistor is so much larger than the upper one. Another question is, what is the Thevenin resistance? So to find the Thevenin resistance, what we do is take the circuit and short out the bottom resistor. So now it just looks like a 12 kilo ohm resistor that goes straight to ground. And I'll write it as if it goes through an ammeter. And I will calculate the short circuit current. So as before with the Thevenin, now ISC. ISC will be just the current through this 12 ohm resistor. So V equals IR, or I equals V over R. So it's V supply over R, or 18 volts over 12 kilo ohm. And back to the calculator, 18 volts divided by 12,000 ohms is 1.5 milliamps. So that's the short circuit current, and RTH is the Thevenin voltage, that is the open circuit voltage, over the short circuit current, which is 17.89 volts over 1.5 milliamps. One last time, back to the calculator. 17.8, that should be 89 volts divided by 0.015 amperes. And that gives me an 11.93 kilo ohm Thevenin resistance. So this is a circuit situation where we have a Thevenin resistance, which is defined by the upper resistor, and a voltage output, which is very close to the input supply. What is the meaning? It means that I could replace this entire circuit diagram with a equivalent circuit that looks like a Thevenin voltage of 17.89 volts and a single resistor in series of RTH and a ground at 0 volts. And so this circuit here is equivalent to this one here, and by inspection I can tell that if I hook up an 11.93 kilo ohm resistor to the output voltage would drop by half, that is from just under 18 volts to just under 9 volts, if I were to add that as my load voltage.